We typically associate the word model with physical replicas, a plastic-scale airplane or a tabletop architectural maquette. Within the framework of cognitive science, a model represents something far more complex, a deliberate act of intellectual alchemy. The capacity to condense the chaotic world into a mental framework is the specific cognitive trait that designates us as Homo Modellus. We observe an environment, apply a specific intention, and make a value-driven choice to extract only the variables that serve our purpose. Success in modeling requires mapping the complexity of reality into a format we can actually use, whether that is a mathematical formula, a line of code, or a musical score. To understand the structure of modern civilization, we must reverse engineer how the human brain synthesizes the noise of the physical world into structured knowledge. Every model relies on 4 dynamic nodes. The first is the object, an infinite expanse of data without inherent structure. The second is the subject. Modeling requires human intent to intersect that chaos, filter out the noise, and isolate specific variables. Karl Marx noted that even the most inept human architect differs from the bee, because the architect builds the structure in their imagination before executing it in the physical world. Note 3 is media. The constraints of your medium dictate the final form. Math produces formulas. Programming produces logic. The final constraint is the customer. The model must be calibrated to the cognitive level and technical requirements of the end user. A true model only functions when these 4 elements, object, subject, media, and customer, align to bridge the gap between internal thought and external utility. How does the brain actually generate an optimized mental image? To find out, we have to look inside the pipeline of the subject. The process begins with sensibility. This is the biological intake where raw sensory data hits the nervous system. The limbic system tags this intake with neurochemical markers like dopamine. This reaction instinctively dictates what we pay attention to and how we value it. Data moves to stage 2, understanding. The brain applies frameworks like time, space, and causality, sorting raw impressions into discrete concepts. A blur of red becomes an apple. Finally, in stage 3, reason, the prefrontal cortex manipulates these concepts, running hypothetical simulations. Reason deduces underlying laws from incomplete data, constructing the final, optimal mental image before it is ever externalized. The human mind operates as an active filtration system, constructing a subjective architecture before any physical action is taken. Once that internal image is complete, the subject must encode it into artificial signs to make it communicable. Charles Sanders Peirce defined the grammar of these signs through 3 categories: icons, indexes, and symbols. The goal of this encoding is representativeness. We are not trying to copy reality. We are trying to optimize its essence for the customer. This is a map of the London Underground, showing the complex web of stations in the city center. The designer of this map intentionally distorted and erased geographical distances and the winding, physical paths of the actual tracks. By stripping away geographical truth, the map becomes an optimized topological network. It provides the navigating customer with exactly what they need and nothing else. Early humans used the same logic. The artists of Altamira isolated key survival data over perfect realism to ensure successful knowledge transfer. Effective media requires deliberate distortion. By stripping away reality, the model reduces cognitive load and maximizes its practical utility. This process scales up from the individual mind to the architecture of civilization, a dynamic explained by philosopher Karl Popper. Popper divided the world into 3 tiers. At the base is World I, the physical sphere of mountains, machines, and biological bodies. Above it is World II, the realm of subjective consciousness, where individual minds filter reality through the cognitive pipeline. At the top is World III, the realm of shared objective artifacts, our laws, our scientific equations, and our software. Modeling is the elevator that moves data upward. It takes the raw inputs of World I, processes them through the minds of World II, and solidifies them into the shared network of World III. These shared models eventually project back down to restructure World I. They allow us to run risk-free simulations in our minds before we physically change our environment.
This three-tiered cycle allows isolated biological brains to aggregate their insights into a shared, engineered reality that persists long after the individual is gone. Beyond the logic of engineering, modeling satisfies a deep existential need. Willem Flusser observed that humans are born into a state of profound isolation. Because we are contained within our own consciousness, modeling acts as the communication protocol we use to bridge the gap between ourselves and others. By externalizing our mental architecture, translating our thoughts into a medium others can decode, we establish a connection to the collective. When a model is understood by someone else, it validates the subject's intent and provides a tangible sense of belonging. This process of active creation satisfies the drive for achievement and engagement, fulfilling the psychological requirements for a sense of purpose and accomplishment. Homo Modellus is not a passive observer of the environment. We are the active re-authors of it. Every framework you build or strategy you design is a model. These tools manage complexity, expanding the boundaries of our existence.